this one? Yes, there we go. All right, that was faster than I anticipated. View. And where is the thing? I'm a Mac guy, so I don't know where.
Slideshow.
Slideshow, thank you. From beginning. All right. Hi, my name is Pablo. I used to be a math geek in Argentina. I realized that becoming a mathematician was equivalent to economic suicide, so I became a water engineer. And I agree, water tends to go down, but it's sometimes not easy to help engineers understand that people need to make decisions based on things that are not equations. I had the fortune to come to the US for a master's and a PhD. I didn't care at all about climate change in the late 90s, but I had a choice to either pay $30-something thousand a year to go for a PhD, or to accept funding in research on the impacts of climate change on Boston's infrastructure. And my choice was pretty simple. Now I can claim that I've been doing climate stuff since the 90s. And it's great, because first of all, I learned back then that the evidence was quite irrefutable, that if we keep pumping this carbon stuff in the atmosphere, it's going to get more complicated. It is getting much more complicated. Now, my first few years as a doctoral student were on impacts of climate issues on Boston's infrastructure. My second half was impacts of climate stuff on farming in Zimbabwe. And quite different kinds of impacts. In Boston, if things go wrong, we have to spend more money. Maybe some people suffer. If we're really dumb, some people die. In Zimbabwe, on a normal day, people are dying. And then if things go wrong, those who are on the edge of survival can get into much more serious trouble. So I started evolving from math geek to water engineer to researcher on climate and disasters to humanitarian worker. And I decided that if we know all the stuff that is knowable about the science of future climate conditions, be it long-term climate change and sea level projections, or the impact of the punch of seasonal conditions because of warmer ocean temperatures, El Nino, on the North Atlantic oscillations, things like that, or something much shorter like extreme rainfall and flooding, or even much shorter like 7 minutes there may be a tornado in Oklahoma. What can we do to help people make smarter decisions? Especially those who are already on the edge of survival. So I started explaining climate science to humanitarian workers, mostly the Red Cross. And what I did was a very, very successful thing. I managed to put almost everyone to sleep. Because if you explain climate science to someone who is a disaster manager and already has hungry people in one district, homeless people in another district, sick people in another district, and in some districts there's the sick, the thirsty, the hungry, and so on, how can you help them pay attention to something as complex and as seemingly irrelevant as climate science? So I was looking for a way to link information, what we know, with decisions, with what we can do, with consequences, the outcomes that we think would be great. And I evolved from showing graphs and equations to designing games and running games with people. So why? It would be nice to know the future, especially if you're a humanitarian organization, that could help you make decisions about what to do, when, and where. We have limited money, limited people, limited resources, money and equipment and the like. Now, the crystal ball to look into the future exists. You've already seen a lot of graphs. This is what the future looks like. And it's great. And being a math geek, I love it. I swim joyfully in those graphs and equations. And this can be all sorts of things from gradients of sea level rise over time by latitude. It could be probability distribution function of precipitation as it relates to temperature gradients. All sorts of things. All of it useful. If you're the Red Cross, with this you can help people change their crops. You can help fishermen decide what kind of boat to buy. You can help shantytown dwellers think how to secure their water, or how to build, where to build. Now, if you're the Red Cross, and you're helping people anticipate future risks, and you show them this, you could as well be showing something like that. Okay? It really doesn't make any sense. And we cannot expect a humanitarian worker to get a master's or a PhD in atmospheric science or marine biology or any of these things in order to make smarter decisions. How do we link information with decisions with good consequences? So what we're going to do now, and please be assertive when I'm running short of time, because I will be distracted, feel comfortable, is to engage in a participatory exercise of the kind that I run with my Red Cross colleagues, Red Crescent colleagues, shantytown dwellers, ministers. We even ran a game in the White House. One of these frisbees was flying around. Now you have to expect confusion. Indeed, our games are designed to push your brain power and your emotional tolerance to the edge of tolerable confusion. Please live with it. Very little background, so this will come back after the game. This is something that arrived by fax and by email to an office in Dakar, Senegal, where a dear friend and colleague of mine, Youssef Aitchelouche, was at the time working as head of disaster management coordination for the IFRC, the Red Cross Red Crescent family. He was covering 28 countries. I won't point, but you can look where those little green pixels are. Just above it, Mauritania. There have been a military coup. Trouble. Bloodshed in the streets. Red Cross needs to help. Not just first aid, but also pacifying and the like. Further to the east, almost the center of that part of the world, Chad, we have refugees from Darfur. All sorts of needs, everything you can imagine. And in the southernmost part of his area, Congo-Brazzaville, there had just been flooding in urban shanty towns, and it's very hard to provide humanitarian services in those conditions. Now, he was dealing with fires of all sorts, and this comes by fax to him. Okay? And he looks at it. And what it says is that this was received in May 2008. It was referring to the coming 3 months, June to August 2008. And it says, extreme refers to the highest 50% of the historical record of precipitation. And the parts in dark green pixel, which is smack in the middle of his area, increased probability, 40 to 50% chance. Now you are Youssef, what do? Do you evacuate every human being where there's a green pixel? Do you put all your tents there? What do you do? What decision do you make if you have little money, little time, little brain power, because you're too busy and you don't have much donor support and so on? This is our challenge. Science exists, shows us the pixels, the data, and then someone has to do something. And by default, what do? Nothing. We don't know. So just in case, do nothing. It's the simplest one. Then deal with the disaster. So, we're going, well, this is what that graph says if you read it in words. I promise you it's still difficult to make decisions. This is a system dynamics model developed by MIT students that illustrates how we could make decisions. Surely you cannot read, but in short, there's people at risk, there's tents that can be moved around based on how much money you have, and here's the core one, decision to act, which depends on a lot of forecast issues. Now, do you flip the switch or not? Do you do something or not? I moved into games. Games are very rich ways to incarnate complex system dynamics. In a game, whether it be soccer or baseball or a simple hide and seek, you have limited information. With that information, you have to make decisions. Those decisions can become action, and the action will become outcomes depending on what you do, what someone else did, and what happened around you, for example, with the rains. And that outcome provides new information for your next turn, your next batting, your next card down, or whatever you're doing. So we thought of doing something along these lines. Now let's play. Enough talking. I will need, there are a few empty chairs on this line. So this row, I need a human being on every chair. So folks from over there, relocate. If the chair is empty, occupy it. I need a human being over here as well. Any volunteer? Thank you, sir. So this game is going to engage everyone in this room. Folks from up there, if you want to participate, come closer. Otherwise, be an observer. It's okay. That one, please. Thank you very much. All right. So each row is a country. Okay? It's a Red Cross national team. You guys are in charge of flood management. If there's a flood and you did nothing, you have to go help people. With tents, with food, with medicine, whatever. This row is made of drought risk management. If there's too little rain, there's trouble. There's other diseases, there's other health conditions, there's other needs. You're the ones doing it. On the floor next to you, you'll see 3 beans. That's your budget. Please pick it up. Right? Some of you already have it in your hands. So raise your hands if you have 3 beans. Good. You are making decisions on behalf of your entire country. The rest of the row is your advisors. So you can hear advice from them, you can hear advice from him. Okay, but the decision is yours. You do what you want. Okay. There's going to be winners and losers. Losers, anyone with red stones. I have a bag here. 1 red stone represents 1 humanitarian crisis. There was a flood, you didn't have enough beans to deal with the trouble, your country gets a red stone. That means people suffering. Okay? Not good. That it doesn't hurt as much in this game situation, but think of it as bad. Okay? You don't want the red stones. The winners will be the ones that end the game with most beans. Will likely play for 4 rounds. Each country starts with 6 beans. You two are countrymates, and so are you two, and so are you two. And you can talk to each other. Okay? You can even share beans within the country, not with the other country. That would be an act of corruption. All right. The winners, the 2 people making decisions for the winning country will win a copy of our latest book, Games for a New Climate, Experiencing the Complexity of Future Risks, published jointly by the Red Cross Red Crescent Climate Center, my team, and Boston University, the Pardee Center. Available online for free, if you want to download it. As well as eternal fame and a bag of Pringles for the entire row. Trying to make this real incentives. Your disaster managers, flood managers, drought managers. Whoops, what did I just do? It's just like that, there you go. Now what can you do? If you think there may be flood, you, sir, can stand up and say, I want to prepare just in case there is a flood. If you stand up, you pay 1 bean. Take a bean and put it on the floor. That's gone. You spent it. You pre-positioned tents for the flooded people. Okay? If you do that before the rains, it's cheap. It costs only 1 bean. And if the flood happens, no problem. Now, if you wait and see, and then the flood happens, it's much more expensive. The road is impassable, the bridge was washed away, so you have to pay 4 beans to deal with the flood after the fact. If you don't have enough, you try to get from your colleague. Okay? Now, how do we know what the rains are? Well, here we are. This is not a die. This is the probability distribution function of precipitation based on the historical record. Okay? So I'm going to throw this up in the air, and it may fall a 6, which means a lot of rain, flood, or a 1, which is very little rain, a drought. If there's a 6, a flood, and you were not standing, you have to pay 4 beans. If you were standing and there's a 6, no problem. Okay? Now we're going to have a half and half. So let's say that up to here, you guys are the southern countries, and you guys are the northern countries. So you'll each have a different die. I'm going to throw over here will be for those up, and over here will be for those. So for example, this is not counting, okay? This is for those up there. The number is a 2. No problem, no flood, no drought. For those over here, the number is 2. No problem. No flat, no drop. So if anyone has stood up, it would have been a waste of beans. Okay? Now you don't know whether or not it will be a waste, because you don't know ahead of time. These are the basic. Here's the synthesis of rules. No disaster, no problem. If there's a disaster and you stood up and paid the bean, no problem. Otherwise, pay 4. If you don't have enough, ask from your neighbor from the same country. If you still don't have enough, get a humanitarian crisis. And I'll bring a redstone to you. Are the rules clear? All right, let's start.
What are the drought people doing?
The drought people also stand up in case they fear a 1. And if there's a 1 and he didn't stand up, he has to pay 4. If he doesn't have enough, he has to get money from you. You don't have enough, you both get a redstone. And including him. So you feel free to come closer and give advice if you have any ideas. All right? Round number 1, you have about 1 minute to make up your mind. You can converse, you can stand up or sit down, whatever.
How many rounds?
4 rounds.
What's the cutoff? So what's the cutoff of you have a disaster?
In case I wasn't clear, a 1 is a disaster drought, a 6 is a disaster flood.
Everything else is okay?
Everything else is okay. No flood, no flood. Okay, make up your mind. Either you stand up or you sit down. 5, 4, 3, 2, 1, and stop. Okay, those of you who are standing, almost everyone on the drought side and more than half on the flood side, please pay a bean and put it on the floor and it's gone. Okay? Good. That means you have paid someone to load tents in your case, food aid in your case, on a truck, pay the driver to go away, and etc. Okay. This is for those in the upper side. It counts. It counts. It's a 5, no problem. All of you who paid the bean, you just wasted the bean. Your donors are really pissed. And guess what? In driving stuff around that no one needs, you've been burning fuel, adding carbon to the atmosphere, increased global warming and climate change. Let's see the other half. A 4, no problem. Everyone sit down. That was the end of round 1. What are you going to do with round 2? Remember, there are 4 rounds.
How did it go in the class?
How did you go?
Well, they have weather resources too. Oh no, they sat down.
And then
We've got a cushion.
Make your decisions. 5, 4, 3. If you're not standing, it's because you're sitting. 3, 2, 1, and stop. Okay? If you're standing, pay your bean. Now we see what happens. Because of the past year, everyone wasted their bean. Now, much fewer investment in disaster preparedness. Right? We do what we should have done the previous time. Everyone paid? Good. Upper team. There we go. It's a 4, no problem. Lower team. It's a 1, a drought. Those of you who are sitting have to pay 4. 4 total. I collected from you. Okay, you're all set. I collected, you're all set. You're standing. Were you in the upper side or the lower side? So you have to pay 4. Oh, okay, yeah.
Now they owe us.
Just for
We have a memory like an elephant.
Oh, all right. Now,
I think we have a question.
no, you all paid 4, right? So if you pay what you have to pay, all is fine. The fact that you have no beans doesn't mean that you have a crisis. It means that you have some limited capacity for the future. All right, have you heard of El Nino? You may sit down, sir, by the way. El Nino is an unusual warming in the Pacific waters that changes the winds and the risk of precipitation and stuff, therefore changing the chances of stuff happening. Where I did my dissertation in Zimbabwe, El Nino means more chances of drought. Just further north in Tanzania, El Nino means more chances of flood. Basically, the rains tend to go north from Zimbabwe to Tanzania. So what we're going to do this coming season, because we have El Nino, is to, instead of rolling this one, we're going to throw this one. Okay? This is going to represent the probability distribution function of precipitation for the north and that one for the south. If it falls like this, it's a flood. If it falls like this, it's normal, no problem. If it falls like this, it's a drought. By falling meaning when it stops moving, right? So it could fall like that. I don't know. I promise I'll do a fair thing. I'll spin it a bit here and fall somewhere. Is it clear? Flood, drought, no problem. You have less than 1 minute to make your decisions. And each team will get its own frisbee. Less than a minute to decide.
Changed dramatically.
But we're good this year. Like, we're in good shape. No, I mean, for the South. So, yeah.
Five, four, three,
This year.
2,
Next year's gonna suck.
1, and stop. Everyone who's standing, pay a bean if you haven't already. Of course, here we trust that you're doing the right thing. You could be sneaking in beans, etc. All right, I'll start with the ones from the upper side. This is flood. Flood. Good news is that you're all standing. Is that correct? Awesome. You're heroes. Heroes of disaster preparedness. Let's see about lower side. May I inquire as to why you're sitting? Oh, you ran out of beans. Why did you run out of beans? All right, you were not prepared for a disaster that happened on a normal season. So when someone comes and tells you, this time around it's looking nastier, nothing you can do about it, and no one comes to you when we know there's a forecast of this kind, you can hear me, right? When we know there's a forecast of this kind, we don't have a budget for extra investments in disaster preparedness. Some prayers are with you. You're saved. Awesome. Now, last round. Have you heard of climate change? What does climate change mean in this game? That's one very elegant way to put it. Among other things, well, I won't say, I will show you the representation of climate change, which will be different for the two teams. For the upper team, do you recognize this object? It's a collar for dogs that went through surgery. So I'm going to spin this little object up in the air, just like I did with the frisbee or the die. And it can generally fall in 3 kinds of ways when it stops moving. If it ends like this, no problem. No drought, no flood. Falls like this, too much rain. Flood, good idea to seek protection. Falls like this, too little rain. Drought, good idea to collect water. One of the ways to prepare for drought is to enhance water collection. So what do you think are the chances of it falling like this, or like this, or like that? Your probability estimation of extreme rainfall under a new climate should guide your decisions. You have 30 seconds. Last round. Oh, sorry, I should show the one for the other team. This one's for the north. And this one's for the south. Flood, no problem, drought. I hear a lot of rich discussions. Let's do this, just to add a little bit of intensity. May I ask all the deciders on this side to please come to the front? Everyone, come. Make it quick. I'm going to ask a question, you answer with your feet. If you're male, go to that end. If you're female, go to that end. Male to this end, female to that end. Okay, so you can answer questions with your feet. We're now going to create a graph that illustrates your estimation of probability. So I want to hear from you, from all of you who are here standing, what do you think are the chances of a flood? If you think the chances are 0%, thermodynamically impossible, touch the wall. If you think it's 10, 20, 30%, stand over here. If you think it's 50% equivalent to a flip of the coin, stand over here. If you think it's 60, 70, 85%, stand over here. If you think it's 100%, every single time you throw it, it's a flood, touch the wall. Is it clear? What do you, and this is your individual estimation. Okay, answer with your feet. What are the chances of a flood? I'll give you a countdown. 5, 4, 3, 2, 1, and stop. How much are you saying, sir?
20%. About 40%.
50?
60.
80.
All right. One object. A wide range of estimations. It's one object, right? And if you ask some, we don't have the time, but some people say, well, based on the bouncing, others say, well, based on the aerodynamics. Different theories, different model algorithms. You've made your decisions, go back to your row. I won't ask about drought, but I imagine it's something about the complement. Go, and actually, the countdown is starting, so you have to rush. 10, 9, 8, 7, 6, 5, 4. So you're either standing or sitting by the end of the countdown. 4, 3, 2, 1, and stop. Those who are standing pay. Note that we have people standing for flood and people standing for drought. Those up there, here we go. Drum roll would be nice. No problem. All of you standing, so concerned about climate change and the need to do as they say to invest more, one data point proves you wrong. Chances are next time you apply for funding to deal with climate risks in a changing climate, no one will pay attention because you just wasted 1 B. Let's see what happens in the lower half. Whoa! Also no problem. Sir, you just wasted your B. Because we played only 4 rounds, and you got fairly lucky, no one got a humanitarian crisis. If we played with 10 rounds and 10 beans, as we did today in Matthias's class, someone will get a crisis. And the crisis means human suffering, right? The keeping beans doesn't mean I win a chocolate or Pringles or book. It means that I have more resources to train my staff, to replace the tires of the vehicle, to build a new hurricane shelter in a place where it used to happen in the past, and so on. So the core issue here is that in your playful activity, you inhabited the complexity of risk. You experienced these information decision consequences. And let me show you something about these two. What are the chances of a flood with this one? 1 in 6. Can you put a percentage on that? 16.6%. What are the chances of a flood in this one? About 50%. Maybe a little less because it could fall like this if it falls on the edge of the table. Well, let me remind you of something we just saw. You recognize this thing? Okay. On a normal year, we define extreme event as having 15% chance of occurring. 15% on a normal year. What do? Some things you do, some things you don't, if you're the Red Cross. Now, this year, the probability is enhanced from about 1 in 6 to about 1 in 2. What should you do differently? What if you do and the disaster doesn't happen? Well, we know that it's a good idea to do some things if there's a right cost benefit and if you have the capacity to do it. Now, Yusef was fortunate to have with him Aram Tal, at the time a master's student from Columbia University, a master's program in climate and society. She was there when the facts arrived. When Yusef saw it and said, what on earth, what should I do? And kept doing his very important and urgent work, Aram said, holy smokes, this is trouble. And she helped Yusef and his team understand how prepared are we for floods in those places with the green pixels. 7 countries did not have a flood contingency plan. Togo, Benin, Burkina Faso developed plans. Teams of disaster responders who, if I am in Benin and there's a flood in Togo, I can have a cape, I can have a Red Cross emblem, I can be Superman. When I want to cross the border, the gentleman or lady at the border is going to say, show me your visa. If you don't have one, you don't cross. But I'm Red Cross and there's a disaster and I am a superhero of disaster response. I don't care, where's your visa? It takes 4 or 5 days to process. So Yusef got a visa for the trained disaster responders to cross borders as needed. Health insurance, refreshment training, on dealing anything from how to mount a tent to paperwork. Asking for donor support before the floods, to pre-position the tents and so on. And then guess what happened? Unfortunately, for some, but thank goodness for those of us who promote the use of forecasts, the rains, the actual observed rains, were fairly close to the prediction. And we did save lives. This analogy worked. And it helps people grasp what it means, that confusing science. Thanks to the training that disaster managers and system dynamics modeling together can develop by developing games, we can make any confusing thing understandable and usable. This is Jano, my partner in game design and facilitation, running a game with Kenyan farmers on cassava, which is a crop that is resistant to drought. With a gender dimension, 98% of the land in the district of Matu is in the hands of men. So no wonder when there's a disaster, women suffer more. This is from a game session at Hanoi University of Science and Technology. 350 students playing a game. You can see Let's Play, and right next to it is Ho Chi Minh. This is yours truly running a game on insurance, index-based insurance bundled to credit, an absolutely incomprehensible and insanely boring topic, which of course no one was getting because it was too confusing and too irrelevant. It sounded like someone wanted to steal their money. They played the game, they got it. Malawi, Ethiopia, now Senegal, with Oxfam America, with the World Food Program, with the support from Rockefeller Foundation, farmers who are illiterate and innumerate. You draw a number, they don't know what it means. They understand insurance. Indeed, because of the game, they helped design it, just like Brian was saying. From the user perspective, they proposed changes to the insurance scheme so that it will be more suitable to their needs. This is a session on the roof of BU, where we were designing game ideas to be taken forward. That's Ben Norskov, one of our former students at the Parsons School of Design. Now he and partners have set up Antidote games, and they're designing games for humanitarian workers. This one was really awesome. It was called Process of Elimination, and instead of beans, there were dark beans and they represented poop. And you had to flush the poop without wasting too much water. And it's an awesome game. Still under development. Last, I think think there's 2 more slides. Why does gameplay beat PowerPoint? First, it's active learning. Not only those here making decisions, but their neighbors were thinking, should I, shouldn't I? What if you do, what if you don't? But if you do and then the other one doesn't, should we both? You know, the brains were active for each and every one of you, and there was peer-to-peer learning. You were learning from each other. And if there's a math geek and a disaster manager and a lawyer, they will be thinking different aspects of the same problem and enriching each other. Plenty of aha moments. When someone thinks or learns or hears something, they say, now I get it. No PowerPoint can accomplish that. It's serious, yet it's fun, and emotions matter. Science shows you stuff people into one of those machines that look at your brain in action. There's plenty of evidence that if you're engaged, you learn more, you remember more, you're more likely to turn knowledge into action. Data collection. I could have asked you to document whether you stood up or not, whether depending on this one or the other one, and then the outcome. And we can analyze that data. I used to be a full-time researcher, okay publication rate. Now I'm a 70% humanitarian worker, 20% consultant, 5% researcher. I've tripled my publication rate. First of all, because I encounter more interesting research problems, but also because with games we get data, and data shows how people think and act in a simplified representation of reality, which mimics reality. So some of you invested too much, some of you invested too little, some of you figure out that if I only had da-da-da, then if I run a new game, you'll play differently. And I can document that learning and show donors, these are the things where we have the weakest points. And of course, Mozambique may be different from Philippines and may be different from Ethiopia. So we can better target how we allocate what we have. Can also be an optimization platform. You get a bunch of people, the donor, the government, the Red Cross, the farmer, the fisherman, and you have few beans, what do you do with it? If the game properly represents reality, it can help people make decisions. And illiteracy, again, no problem. That's our website, www.theclimatecentre, not the British spelling, .org. And these are some of the organizations we have designed games for or with. CDKN, our most prominent donor for now. The American Red Cross has also been very smart and generous. World Foundation, World Bank, all sorts of people. And what we hope to do is to recruit brainpower from places like Northeastern, which I'm very happy to see how unusual you are in relating to the real world, in having your undergrad spending 1 more year so that they actually get their feet on the ground and learn and do. We need your brain power. We look forward to working with you. Thank you so much for your attention.